revision session. Okay, so today I want us to look at an interesting exam question which is coming from this topic. As you can see, it's ammonia, specifically the Haber process. Okay, so we're going to revise this question together. We're going to answer this question together, and I want you to get your pen and paper and let's get started. So here is the question paper. Okay, I just extracted this from 2024 science, okay, which is the combination of physics and chemistry, but this part is chemistry. Okay, right, so here are the questions. Let me read the first question. Okay, first one, this B8. Ammonia is manufactured industrially in the Haber process. Ammonia is manufactured industrially in the Haber process. A. State the chemical formula for ammonia. State the chemical formula for ammonia. So before you answer this question, you must understand that ammonia is made up of 1 nitrogen atom and 3 hydrogen atoms. So its formula would be written like this: NH3. Okay, let me just write it properly there. NH3. Okay, so 1 nitrogen atom and 3 hydrogen atoms. So this is the formula for ammonia. We continue. Question B. Question B. Is ammonia an element, a compound, or mixture? Give a reason for your answer. Now, here, before you answer, you must understand what an element is. You also must understand what a compound is. You also must understand what a mixture is. This is very important. Okay, so let me explain for you to understand. So an element has only one atom or one type of atom. Okay, that's an element for you. What about a compound? A compound has what? Can have 2 atoms which are chemically combined together. All right, so these are chemically combined together. So a compound is chemically combined together. 2 different elements can be there, such as nitrogen and hydrogen, but they are chemically combined. That's a compound for you. What about a mixture? A mixture is not chemically combined or chemically bonded. Okay, so from the explanation you can see that ammonia, let me just do this. Ammonia is a compound. Ammonia is a compound. Why? Because it is made of nitrogen and hydrogen, which are chemically bonded. Chemically combined or bonded. Okay, so ammonia is a compound. Let me use a small rubber here. So ammonia is a compound. Ammonia is a compound. Reason, this is the reason here, because it is made of nitrogen. Okay, let me also wrap this so that I write it properly. It's made of what? It's made of what? Nitrogen and hydrogen. Nitrogen and hydrogen. And you have your 2 marks. We continue. C. Write a balanced chemical equation that takes place during the Haber process. Chemical balanced equation that takes place in the Haber process. Okay. Now, before you actually answer this or you write this, you must understand that nitrogen reacts with hydrogen to form ammonia. Nitrogen reacts with hydrogen to form ammonia. Okay. And the equation must be balanced. So which means we're going to have 2 nitrogen atoms and 6 hydrogen atoms. And this is how we're going to write it. Okay, so we have our N nitrogen plus, okay, 2, okay, we have this and that. This means the reaction is reversible. Okay, the reaction is reversible. Let me write the symbol properly. The reaction is reversible. Okay, I'll use my red pen. Okay, and that way. Okay, so we have nitrogen and hydrogen. Okay, and here we're going to have NH3. So this equation is not actually balanced. We need to balance it. Okay, we need to balance it so that we have 2 nitrogen atoms and 6 hydrogen atoms. So for us to balance it, okay, we add our 2 there, okay, and we add our 3 there. So this one is actually balanced. We have 2 nitrogen atoms and then we have 6 hydrogen atoms. Balanced. Okay, so this is how you answer this particular question, and you have your 1 mark there. The last question, D. State any 2 conditions necessary to maximize the yield of ammonia during the Haber process. So you must understand, during the Haber process, there's a certain temperature that is required, should be 450 Celsius degrees. Okay, and apart from that, the examiner can also ask you which catalyst is actually used to speed up this process. Remember to mention iron. Okay, iron is one of the catalysts that is part of the Haber process. Okay, iron catalyst, it's actually added in the chamber. Okay, and after they have compressor, or rather they have compressed with high pressure, which is heated at 450 Celsius degrees, they add the iron catalyst. Okay, and then ammonia is actually produced. After that, there's a cooling and condensation process that takes place. Okay, so the 2 conditions necessary: number 1, high pressure. Okay, let me use my green pen. Number 1, you need high pressure. So high pressure. Why do you need high pressure? Because the reaction makes fewer gas molecules. When we have a high pressure, the reaction will make fewer gas molecules. All right, so high pressure favors ammonia production. So the simple reason you can give is high pressure favors ammonia production. Okay, number 2, what other condition? We need a moderate temperature. We need a moderate temperature. We need a moderate temperature. Number 1, we need a high pressure. Number 2, we need a moderate temperature. Why? And this temperature must be relatively low. Okay, so this must be relatively low. Very important. So you need high pressure, okay, so that the reaction can produce few gas and more production of ammonia. And we need moderate temperature. Why? Lower temperatures give more ammonia, okay, but low and very slow. This will be very slow. Okay, so you need the moderate temperature so that we have more production of ammonia. Okay, so basically this is how you answer these questions. Okay. Thank you so much for actually joining me. This is the end of our revision, and I would say it's bye for now. See you in my next chemistry revision session.